Hello everyone, this is our next installment in working with Python. And last week we did single variable regression. This week we're going to do multiple variable regression. We're going to do it in a little bit of a different way. I'm going to show you just another way to get it done. It's not too different, but it's using sort of like a mini function that we build partway through this script. Let me run through the script real quick. We're going to use the Boston housing data set for this demonstration, but your assignment is actually to use the Toyota Corolla data set, which I will import into the, or have imported by the point that I post this, into the module for Module 5. In the first section, what we're doing is we're importing our libraries. So we're importing pandas, this is PD, we're importing, and we're just doing kind of a little bit of a different way on each one of these. I don't know that there's really a whole lot of difference for what we're doing. But for the next one, it's NumPy, and we're going to just import all of it. And then we're going to import matplotlib/pyplot as PLT, like we've done in the past. And then we're going to import sklearn. From sklearn, we're going to import linear model. Linear model is what allows us to sort of build our little multifunction, our little model that we're going to build partway through this. So those are the standard libraries that we typically import. Next, we'll go ahead and run that, actually. Next, I'm going to set up my working directory. I always have to do this to be able to find my files. So I import OS, and then I do OS get current working directory, which is always set to curtd downloads. I have to change that to documents because I want it to pull it out of documents. So I use OS change directory, and I specify in single quotes the full path name for documents. Once I've got that, I'm ready to use the pandas read CSV function to read in Boston housing, and I set that equal to df for data frame. So all that can be done. And then I'm going to look at my data frame and just you type in df and it just shows you your data frame. And that's what's going on here. This is all very familiar to us. We've seen this data set 100 times. Quite possibly 100 times by now. So everything looks good. Okay, now we get down in here and we're going to do a mini function called reg. Reg is actually, it's sort of a mini function, sort of a model, if you will. And it's essentially the linear regression model. I got to spell that correctly. L from sklearn. So we'll set reg equal to linear underscore model dot linear regression. Linear underscore model was specified up here when we brought in sklearn. We said bring it from sklearn, bring in linear underscore model. That's all good. That's kind of the main library, and the part of the library that we're actually going to use is a piece of it called linear regression, open paren, close paren. So reg is equal to that. And that's kind of our little function that we have set up. We just basically made it equal to the linear regression model out of linear model. Then we use that mini function to actually run the multiple regression. So we use reg, and what we do is reg.fit. We're going to fit a model. And what we're going to do is we're going to go back to our data frame, and we're going to pull in 3 columns. Those columns are room, age, and LSTAT. And they're in single quotes, and the name of them are in capital letters because that's what matches the first row of the data frame. And then what we're also going to do is we're going to bring in the field that we're trying to predict. So in this case, it's df.medv. That's a little different, right? df, we specified the actual columns that we're bringing in, all 3 of the columns, and that's in double square brackets. And those are the 3 values that we're bringing in, and we are going to use those to fit the median value that is also in the data frame. But in this case, the actual syntax is just a little bit different. We specify the data frame, then we specify the field that we are trying to actually fit for or predict. So we do that, and that takes care of building our model. All right, down below it gives us this line, it says linear regression, and that gives us all these parameters here. Basically, this is just telling us that it ran. So we have a model, and that model actually lives now in this reg function. So we can take a look at a couple things. First of all, we can look at the coefficients. There are 3 coefficients because we have 3 variables. So we have a coefficient for room, coefficient for age, and a coefficient for low status. So when we want to look at those coefficients, we type in reg.coef underscore, and it will give us an array of 3 coefficients. And those are our coefficients that we would use if we're going to plug them in and actually calculate the predicted value. So it would be room times 5.019, etc., age times 0.0090, and LSTAT times negative 0.6685135, or 305. Okay, so those are our coefficients. But as you remember from multiple regression, we also have to have an intercept. And the intercept is found by doing reg underscore intercept, or reg period intercept underscore, and that gives us our intercept, and our intercept is negative 1.175, and so on. So those are all of our values. And what we normally would have done in R is that we would have just built a big line to set a new variable called predict, and we would have plugged all those numbers in. But we don't have to do that, which is nice about this. The use of the reg function allows us to take the model that we dropped into that and just apply that directly to the data set. We don't have to plug in all those numbers. This is particularly nice when we don't know what the numbers are. So if we're going to go ahead and build a model and we're going to feed in multiple data sets, in the old way, we would have to go back and change all those coefficients in the intercept every single time we reran the model with new data. Now we don't have to do that because it will do it for you. So it'll store, every time you run the model, it will store new coefficients and it will store a new intercept. And so what we do in this case is we say our data frame, and we name a new variable called predict, or PRED, you can name it whatever you want, is going to be equal to reg.predict, which is just another function of reg. We started up with reg here being set to linear. Then we have reg fit, reg coefficient, reg intercept. Now we have reg predict. And then we are going to use, from the data frame, we're going to use room, age, and LSTAT. So basically what we're saying here is create this value of predicted and use that by running the model that we just built on every instance where we have room, age, and LSTAT. And if you remember from this data set, there are 506 rows, so it's going to build you 506 appropriate predicted values. And it's going to do it right into the data frame. So where there's 14 columns, now there's a 15th column, and that's going to be predict. And so that's really nice. It's really nice and clean that we don't have to actually specify those because the model specifies it for us. Then we can also specify the error. So we create a new field called error. df error is going to be equal to df predict, which we just created, minus df and the actual median value. And so that will create a whole, I think, 16 columns from doing the column count, right? That's just the error, the residuals. And so that's now new in there. And if we want to take a look at it, we can just do a df at this point, and we can actually see what's in there. Let's actually catch up on all this. I haven't run all these. So run this. There's our coefficients. There's our intercept. There's our building the predicted values for all 506 rows. And there's the error for all 506 rows. Now we want to take a look at what our mean squared error is. And this is very similar to what we did with single variable linear regression. The mean squared error is basically equal to the mean of the value of error squared. So we'll, first things in order of operations, we'll square error for each one of the 506 rows, and then we'll take that, the mean of all those squares. What we could also do is we could take the square root if we wanted to get down to kind of what really the error is, but we know that it's the mean, and that's why the value is so high. Then we're going to run a coefficient correlation, or correlation coefficient, I should say, and we're going to compare the real median value to the predicted median value, and that's going to give us an idea of how well our model is doing and how good it is at predicting, and it's about at 0.8. So that's pretty good. It's not great, but it's pretty good. Now let's take a little bit of time to set up for a plot. I want to see a scatter plot, and I'm just out of convenience, I'm going to, instead of typing df predicted and df median value every time, I'm just going to set this equal to x and y. It's just easier. So when it comes down to actually setting up for the plot. So I do that, but that's just a matter of convenience. I come down and get ready to configure my plot. I've got the titles and the labels. Plot title, very similar to what we've done in other scripts. I say actual median value versus predicted value. The font is going to be Times New Roman, and the font size is 20. I have a Y label and an X label. I have median value and predicted value. I'll go ahead and generate my plot. So plt.scatter, xy, and plt, of course, is from matplotlib pyplot. So, and then I can, once I've got my scatter plot, I want to do a couple other things with it. And one of the things I want to do, this is new, a new way of doing this, is I want to set up my plot and then put a trend line on the plot that shows kind of what the trend line should look like relative to the dots on the plot. And so I'm going to use the polyfit function, and I'm going to say z is going to be set equal to polyfit xy1. The xy is just, you know, what, the 1 is the type of line, and the xy is what exactly is it that we're looking at. We're looking at x and y as compared to each other and how well they fit in a sort of a polynomial situation. P is equal to poly one dimension z, so we basically take P and we derive it by looking at poly one dimension z, which z was of course set to equal polyfit xy1. And then we just plot it. We plot x, and we plot P as a function of x, and the r dash dash means make it red, make it a dashed line. What basically this is doing is it's saying, take a look at the position of X and Y and draw me a line that's going to be as close as possible to all of the values that are on this scatter plot. This is kind of the root of regression. The first part of regression is the least squares. And that is, again, what we're doing is building a line, putting a line through a scatter plot that is as close as possible to all of the data points. And that's what this function is doing here. These three lines here is basically setting up a line that is as close as possible to all the data points and then plotting it. And then the last thing we do is plot show, which actually shows us the plot once we've built it. So we can come down here. I think I need to run these and run the plot. And there it is. So we have our median value. We have our predicted median value. We know that we have a correlation coefficient of 0.8. And there is our red line that is showing us what the trend line looks like. And it looks like it is, as close as possible to all of the data points. And it's, the best fit line. Okay, here is your assignment. I would like you to run through all of these steps, but I don't want you to use the Boston housing data set. When we did multiple regression in R, we used the Toyota Corolla data set. So what I would like you to do is basically run through that function. And I can't remember the exact names of the fields, but if you do a display of the fields, you'll be able to tell. We were trying to predict price, and it was as a function of the kilometers, and then two other fields. I think it's age of the car and one other field. And I'll go ahead and make a note of that when I actually post it. Well, what I want you to do is go through the script and I want you to modify it. I want you to modify it to accommodate that data set and see what you can get out of that data set when you set it up to predict the price of the Toyota Corollas based on the three fields that we used when we did it the first time. So that will be your assignment for this week, and let me know if you have any questions.